Okay. Give me 1 second, please. All right. So,
Sir,
yes.
there's a clash with A2C. And I didn't want to ask you to check this
There's a clash with what?
A2 chemistry.
With AS? Your clash?
A2 chemistry. A2.
18. Okay.
Monday, Tuesday, Wednesday.
With this class, right?
This class, yeah. I'm so sorry.
Okay. Let me check with Sir Numan, all right, today, and then I'll let you know.
Okay. And sir, is this recorded and you will post it?
Yes, it is recorded.
And Sir Numan doesn't record his videos, so can I leave?
Yes, yes, sure.
Me too.
All right. So,
Sir,
yes.
can you rename the recordings chapter wise? It's really hard to find any.
Yes, I'll do it today. I'll get it done. All right, don't
Yeah,
worry.
just chapter wise rename it. Thank you.
Yeah, can do. Okay, we'll do that. Okay.
Sir,
Yes.
there's a lot of background noise.
A lot of background noise. Okay. What about now? Is it okay?
It's the same.
It's the same. Wait a second. Give me 1 second, please. Okay, is it better now?
Yes, sir.
Yes. Okay, good. Okay, so now we're basically talking about power. Power is defined as work done per unit time. Now, the SI units for power are watts, and it is basically a scalar quantity that I can tell you. Now, so power formula can be written as energy over time, or power can also be written as work done over time, right? So these are general formulas we know. But with respect to this, we can actually change it because we know that work done is force times displacement. So I can basically put it right into this. And then I can write power as force times displacement over time. Anybody has any issues with these?
No, sir.
No, sir. Now check this out. If I say that power is force times displacement of time, what would be displacement over time then? You guys know that?
Velocity.
Velocity, right? So then I can replace it here. That means that power can be written as force times velocity as well. Get it? So now we have three formulas. We have number one, power as energy over time, or we can say work done over time, or power is force times velocity as well. Get it? Understood? Okay, write this down, please. All right. Is the sound any better now? Okay, that's pretty good.
Sir.
Yes.
So, like, you send these notes and stuff, right? Is there a way, like, can you do it in that theme?
What can I do? Sorry, come again.
Can you make it in that theme? Like, change this white to black.
White to black. I can do that. Then the issue is that you won't be able to print them, Asma. That's the biggest issue.
Can you still add? Can you print them? The link you sent.
Yeah, you can print it. You can print them. You can just press Control P. If I do it in black, then your printer will lose all the ink on
Yeah,
them.
I
Yeah.
get it. Yeah, okay.
And-
Yeah, fine. Thank you.
okay. So, what do you say? Should I go forward now? Okay. Now I'm going to give you one question. All right. In fact, I'll do that first. Let's have a look at that. So in this example, it says an escalator is 60 meters long and lifts passengers through a vertical distance of 30 meters. All right. Now, then it says power needed to overcome friction is 2.0 kilowatts. नहीं दे दिया मैंने. Thank you. All right, 2 kilowatt. Considering each passenger is 60 kilograms, how much power is required to carry 20 passengers to the top? If escalator drives at 0.75 meters per second, like that. Okay, kids. Okay. Now, so they have also given you a diagram like that and like that. So the escalator looks like this. This height, by the way, is given as 30 meters, and this length from here to here is 60 meters. In fact, let me just put it here. It's even better. Wait. From here till here, it's 60 meters, like that. Is it clear, everyone? So basically, people are on it, and these people are going at 0.75 meters per second. Can you guys try to do this? See if you guys can work it out, and then I'll explain it. All right, you guys could do this. Anyone has an answer?
So I got 11,000.
11,000 kilowatts as the total power needed. Okay, that sounds correct. Anyone else has a different answer? Shazib, Furkan, Farina. Asmaina, fun. Okay. Now, you guys, first of all, I would like to tell you a few things. Okay. Like we did yesterday, I told you that there are like the power is needed for these people to go up, which have this directional velocity, right? So if I were you, I would first try to find what would be the angle here, because if I want to find the weight of these people, so I know if the weight is W, then I have to do, because this is a slope, I have to make two components like this and like that. If this is the angle theta, So then the force they need to work on is the force of W sine theta. Do you guys agree? Because they need to take, people up, and they're doing, work on the parallel force right here, right? So then I should know that if this is the force is W sine theta. I can find W because we have we have 20 people, and they have 60 mass of each person times 9.81. So this will be W times sine of theta. Do you guys get it? Now, interestingly, we do not have sine theta here, but we can find this because you see, this whole thing is a triangle. This side is 30, this side is 60, this is the angle. So sine theta would be perpendicular or the opposite over the hypotenuse. Do you guys agree? I'm going to replace this right here. And if I do that, it's going to be force equals to 20 times 60 times 9.81 times, instead of sine theta, I'm writing 30 over 60. Get it, you people? Now,
Sir, won't we have to do sine inverse then? 30 over 60.
no, why would I do sine inverse? Because this is opposite and that's adjacent. Sorry, hypotenuse. So sine theta is opposite over hypotenuse, right?
But we want theta, right?
No, you can find theta as well, but I've replaced the whole sine theta with this value because sine theta is equal to this, right? That's why I put it directly. You can find that, you can find the angle and also that as well, right?
Okay.
You can put the angle, but that would be an extra step, right? You just need an extra step. Like if you find theta by taking inverse and put theta again, it would give you the same answer. You want to try? Let's see. So you see, if you do 30 over 60, Farina, it will be 0.5. You agree? Now, if I find sine inverse of this answer, what do I get? 30 degrees, right?
Yes.
Now, this one is 0.5. And now check this, sine 30 is 0.5. So it doesn't really matter. Do you get it?
Yes. Okay.
Yeah. Now, if I calculate this, so it's going to be 20 times 60 times 9.81 times 0.5, and I'm going to get 5886 newtons. So this is the total force that we need to do work on, right? Now, we also know that we need to find the power, and I'm going to choose a different color. So power is force times velocity, okay? Now force is 5886 and the velocity was 0.75. Here I want to make an important point that you should have force and velocity must be parallel. And this is the reason we are taking this component of the force. Understood? Now, if you try to calculate this, so you got to multiply this value with 0.75, it's going to give me 4414.5. So 4414.5 watts. I'm going to change this into kilowatts, so it's going to be 4.4 kilowatts. Can I write it like that? All right. So this power that we found is to raise people to top. But then we need to find the total power. So the total power must be required, the power to raise people plus the power that we need to spend on overcoming friction, right? They have already given that in the question, which is 2 kilowatts. Oh my God. It's 2 kilowatts right here, as you can see. So I'm going to put basically 4.4 kilowatt plus 2 kilowatt. So the total is going to be 6.4 kilowatt, and that would be the answer. Okay, Asma. Why do we, so Asma is saying, why do we need to find the weight? Now, Asma, check this out. Basically, the whole diagram is a triangle, all right? So if, let's suppose all these people are here, right? So the people will have the weight downwards. You agree? This is the angle theta. So when you take two components, one component has to be perpendicular to the slope, one has to be down the slope, right? You've done that in forces. So that would be angle theta. This will be angle theta. So can I say this is W sine of theta then? Do you understand? Now, this is the force we need to overcome in order to take these people to the top. Understood? So this is that force, and because all of them are going at 0.75, so that would be this velocity to find the power. So that's why we're finding the force. Understood? Okay. So remember, like I said, you have to find the force or the velocity that is parallel to each other. That's how you can find this power. And this is why the formula power equals to force times velocity is so important, because most of the questions are going to be with respect to this. Get it? Good. Very nice. Very nice. You can copy this down, please. And do let me know. Shazib, you clear about everything? Furqan, what about you? Good, Shazib. Imal, did you check your mistake? What mistake did you do, by the way?
So I did not do the components.
Yeah, you're never going to forget. Don't forget about those. That's so important. Well, there's another way of doing that without the components, but that's a longer method. I would not recommend that. That's when you can take the weight and this height, you can find gravitational potential energy gained, and then you can find the time it would take to travel. So should I also do the alternate way, if you don't mind?
Yes.
Okay. So there is another way of doing this, but that's a bit, different. So I'm gonna basically write here alternate way. So let's suppose you forget about this formula and you're stuck. So don't worry. So I'm gonna draw the diagram just for our own, understanding, like that. So now check this out. So let's suppose these are the people. They're going at 0.75. This distance from here till here, we know it's 60. And that distance is 30. Now, we're saying the weight of these people are acting downwards. So now we need to understand basically the work that we need to do is against this one. So I'm going to say that the weight of all the people would be 60 kilograms times their 20 people. So total mass would be this times 9.81. Okay. So the total weight should come out to be 60 times 20 times 9.81. That would be 11,772. 11,772 newtons. You guys agree? So that is the total weight we're lifting, right? Now, the gravitational potential energy that must be gained in order to take people from this point to this point would be the force that we are working against, mgh. So the weight is 11,772 and the height would be 30 then. Do you guys agree? So then we're going to multiply this with 30. So I'm going to get 353,160 joules. Now I need to find power in doing that, right? I know that in order to find power, I need to basically divide it with time, energy with time. So I need to find the time. So the total time that they would take to move from this point to this point would be time is equal to displacement over velocity. The total displacement they've moved is 60, and the velocity at which they're moving is 0.75 meters per second. Do you guys agree? So that way, 60 times 60 divided by 0.75 is going to be 80 seconds. Please check the answer if I'm correct. That's just in my head. Okay. Okay. Then what you're going to do is, when you do this, now you can find the power. Power is energy over time. So it's 353,160 divided by 80. I believe, please check if it gives you the same answer like the previous one.
Yes.
Okay, you can do this, but I need to teach you the components one as well. Sometimes you don't give you components. So yeah, so this would be 4.4 kilowatt. Now the power that you need to find, the total power would be 4.4 kilowatt plus the power needed to overcome friction. So it would give you 6.4 kilowatt as the answer. Asma, sometimes you have to, do components sometimes. So we have to learn both of them. It's just not, it's sometimes not a choice, right? In this one, it is a choice, all right? So we can do this, it's all right. Is it clear now? Yes, very good. So you can copy this alternate way as well. And then we move to the next question. Then I'm going to teach you something very, very important. And in the next question, and by the way, I'm going to surprise you in this, but this is an MCQ of your paper. So that would take good 5 minutes out of your time, at least, if you're like doing everything right. So what I'm saying is, in any case, if you get a question like this in the paper, it has a lot of working. Do the fact question, like the definitions and the formula questions first, and then leave these type of questions at the end so that you can, spend more time on that. Do not stay stuck on these sort of questions, because then you are compromising the other ones. All right, so you have 1 hour, 15 minutes for your paper, and it's best to leave them for the end, right? Okay, now I'm gonna go to the next. You guys have copied this? Furqan, you have copied everything? Farina?
Yes, sir.
Okay. Furqan, are you there? Today you're not saying anything. Why? Okay. Now let's move to the next, all right? So the next question is, seems simpler, but I don't think it's simpler. So let's have a look, and we'll learn a way to tackle these questions as well. So example. So in this question, it says a wind turbine has blades that sweep an area of 2,000 meters square. Okay. Now it says it converts power available in the wind to electrical power with efficiency of 50%. All right. Now it says, what is the electrical power generated if wind speed is 10 meters per second, and they have also told you the density of air is 1.3 kilograms per meter cube. All right. Okay. Now, please try this now. See if you guys can do that. Furkan, are you there?
Yes, sir.
Okay. Furkan, have you copied everything before this?
Yes, I am copying.
Okay, very good. If you do not understand something, just ask, all right? It's okay.
Sir, only the area is given, not the volume.
Nope, no volume.
Isn't there like a height or anything too? Like,
Nothing. This is all the question that is. You need to find the electrical power.
why do they do this with MCQs? Like, for one mark, they make us suffer.
And that's how A levels is. That's what I'm trying to teach you. Don't worry about that. Okay. Should I help you now?
Yes, sir.
Okay. Now to do these sort of questions, and there basically every time there will be one question like this. So let me tell you this. First of all, check this out. What are we trying to do here? If something is moving, what kind of energy does it possess? Can somebody please tell me that?
Kinetic.
Kinetic energy. Good. So we can say kinetic energy is given by half m and v, right? You guys agree? Do we have the speed in this given anywhere in the question?
Yes, sir.
Yes. Do we have the mass of the air passing?
No.
No. It means we got to find the mass. In the same question, they have given you a clue. They have given you density. Can you somehow find mass from density? Do you know the formula?
Yes, sir.
That is density equals to mass over volume. So this would be the second thought process that I have. Do you guys get it? Okay. Now think about it this way.
Sir,
Yes.
So why did you write the V square in the kinetic energy?
I forgot. Sorry. Is it clear? Now, in this same formula, if I have to find the mass, I need to multiply density with volume. Correct? But now we need to understand that we do not have volume, right? So if I do not have volume, to find the volume, can I say volume is area times length then? Can I say that?
Yeah.
All right. Because we have the area, now we do not have the length, right? So we're going to go further. So how do we find the length of what air moving? What is the length of air moving? Basically, these are the area of the plates. Obviously, they're moving, and when they're moving, the wind is going like that. So when it passes through it, basically how much length of air is passing in 1 second. We can do this by velocity equals to length over time. We have the velocity as 10, and I want to find what would be the length in just 1 second. So can I say in 1 second, 10 meters of air passes? Can I say that, please?
Yes, sir.
Okay. Now I'm gonna, once I reach to a point where I have actually found everything, I'm gonna go backwards. Yes, basically, Asma, it's displacement over time, right? So whatever we're doing, we're saying that if this is air, air is basically moving. So what is the length of air that passes through the blades in just 1 second? Do you get it? So the displacement will be length, time will be just 1 second. So 10 meters of length is going to pass. Get it? When you have all of this, what you're going to do is you're going to go backwards. Just go backwards. So now here, 2000 is the area, length is 10, so it will be 20,000 meter cube of air passing in 1 second. Get it? Then backwards again. So density was 1.3, volume was 20,000, right? So can you find the mass then? 1.3 times 20,000 is what?
26,000.
20. So we got the mass of air, that is 26,000 kilograms. That's basically moved in 1 second, right? Now we have the mass. We're going to put it here. Half times 26,000 times the velocity is 10 square. Can you find the kinetic energy? I think it's going to be 13. And then 13,000 into 100. That would be
50.
Yeah, 5 zeros. So this would be the kinetic energy. Understood? Now we got to find the power, right? So the power would be energy over time. The total energy was 1300,000, and that just happened in a time of 1 second. So the power would be 13,000 watt. Get it? Now it says only 50% is converted to electrical power. So the electrical power would be 50% of what we have found. And that would be, half of this is going to be 130 divided by 2 is 65. So 65,000 watts. Is it clear? So I just want to basically tell you people that these sort of questions, you guys need to understand that we have to basically go to each term that is missing, try to find it. And if some term is again missing, we have to keep on going till the end and then go backwards. You will be able to solve this question or any question of this sort. Understood? Oh, my chai is cold. Yes, they are very common. You will find these questions like 3-4 questions of these types of different chapters in each paper. So you guys need to prepare. You have to learn the method that I've told you. All right, and it's very logical. If you see that you're finding each, yeah, it's P1. P1 is the hardest paper. P2 is very linear, I'd say. You just put in the formulas. You should have the right definition learned, and P2 is not that hard. P1 is the real exam that you got to look for. Understood? Yes, Asma, that's true. That's true.
Yeah.
Yes, Amal.
So we have a choice of taking we have a choice of splitting or taking the full A level, right?
Yes, but then it becomes even harder if you take full A level at one go, because paper 4, A2 paper 4 is also very hard. So let me tell you one example, okay? Out of 100 marks in paper 4, people get an A in the component at 55, 56, 57. So you can imagine how hard that would be, okay? So you got to prepare. You can't take that chance. Is it clear?
Yes, sir. But then, if we do paper 4, if we complete the whole syllabus of A level, then paper 2 and paper 1 will be nothing, right?
If you yes, you could say that, but paper 1 is still MCQ. So yeah, no, paper 3 is not very hard. You just need to I will help you with that. It's okay, but you should keep on joining your school labs. Those are important. All right, so now speaking of efficiency, you guys have copied this. Should I go forward now? Okay, guys. So speaking of efficiency is quite simple. It's just O-level stuff. That's right. Efficiency is basically defined as the total input equals to, basically this is the formula that we need to know, the conservation formula, goes into some useful output plus some of the energy or power is wasted. So this is the main formula. The symbol for efficiency is this N. It's called, by the way, eta. And the formula for efficiency is useful output over total input times. Okay, so this is efficiency. If you want to find the percentage, you just got to multiply this with 100%. That is all you need to know. So this is basically very simple, just like O levels, it's same. Just remember, I just want to tell you, it's a ratio of same quantities, which means that it would have no units. So that's something you guys need to remember. Okay, any questions now? Please let me know. All right, Farina, everything is clear. Furqan, Shazib, please write this down. Yeah, okay. Imal, Asma.
Yes, sir.
Okay, now let's go to the next. Yes, we will discuss the worksheet very soon. Yeah. Okay, so now the last thing we're going to do, let's complete this chapter. So tomorrow we can discuss some of the worksheets that are left and maybe start the new one. So relationship of work done with pressure of gas. So this is a very simple derivation. You guys need to learn this, by the way. It comes for 2 marks in paper 2, can also come in paper 1. So basically, if you have, so suppose a piston looks like this, syringe or piston, whatever you're looking at, and okay, like that. And this piston, by the way, is movable from the side, like that, and it has a plunger as well. Like that. Okay. Now what you guys need to remember is that if I apply a force on it from here, this plunger is gonna go somewhere here. All right, so it moves like this. So I just want to tell you that when it moves like this, obviously it will cover some displacement like that. You guys agree? Also, this plunger will have some area like this. All right, so all of this that you see is the area of the plunger that also moves, which stays the same, by the way. So, that's not good. Okay, so basically it stays the same, and like this. All right, so the first thing we should remember is with derivation that work done is force times displacement. All right, good. The displacement that we moved is x, so we can say that work done will be force times displacement x, like that. The other thing we should understand is that, let's call this the first equation. The pressure is given by force over area, and force is given by pressure times area, like that. Do you guys have any issues with that? Now, if I draw a 2D diagram of this, like that, so what you should understand is that it was here initially, and we were forcing it inwards here. So now it has moved to a new location, like that, and the displacement it has covered is x. And before we had this whole volume, which we can call as initial volume, and now we have only this much volume left, which we can call as the final volume, right? So what has this force done? It has caused a change in volume, and that is because of the area times x. Do you guys get it? Right? What I'm saying is, initially, you see, it had all this volume available. You agree? Now,
Yes.
when you push the plunger, when you pushed it here, don't you think only this volume remains?
Yes.
So the change in volume, which is the final volume minus initial volume, is basically because the plunger has moved a distance x within area A. Get it?
Yes, sir. That's the volume of the right side, right?
Yeah, it's the volume, this volume. You can say that. Yeah. Get it? Now, if I say that if you look at this, can I just put the force right here? Can I do that, please? In equation 2. Then I will have work done as pressure times area times x. Can I write it like this? Would you mind? So then this part of this equation is right here. So I will write work done will be pressure times change in volume, and this is the part we need to show as the derivation. Sometimes it will give you like this, sometimes they will give you as pressure times Vf minus Vi, but that's the same thing, final volume minus change. It's change in equation. Now, the most important thing in this question is that this equation is only valid for constant pressure. It doesn't work for anything else. Get it? All right. Now, the questions of these are so simple, like they're the easiest questions ever. So you guys can copy this, then I'll give you a question. You guys can do that, and then we'll end the class. See you tomorrow then. Today I will ask one of my office persons to convert everything to the right names and put them in folders for the recordings.
Sir,
Yes.
sir, V final would be lesser than V initial, right?
Yes. It doesn't
So
really
it's a
matter at
negative
the end.
value.
Sorry?
So it would be a negative value, right?
Yes, you can say that. But work done is not negative. Generally, what we do is, what you need to remember is, because you see, volume is scalar, right? And whenever you're finding scalar, usually when you're using the formula, you always put larger value and then you subtract with smaller value. So your answer will always be positive. But work done cannot be negative, at least for now. You can say that, but in A2 we learn when we can take it as negative and positive. Right now it doesn't matter. Is it clear?
Yes.
All right, Farina, Furqan, Shazib, you guys written this? Okay. All right, now up on to the question now. Furqan, have you written this? Please tell Asma about you. Okay, so now let's do the question. So I'm leaving this question for you to solve. So it says the volume of gas in a syringe is 2.0 centimeter cube at room temperature and atmospheric pressure of 101 kilopascals. So it says, what is the work done by gas if it expands to 6.0 centimeter cube? Now, I just want to leave you with the answer. The answer to this question is 404 millijoules, and you guys need to convert centimeter cubes and kilopascals to SI unit before you start doing that. Is it clear, everyone?
Yes, sir. That's it. In the above one,
Yeah.
the above formula, work done equals to pressure times final volume minus initial volume.
Yeah.
You said it's only applicable for constant pressure. Is it the
Yes.
pressure of the atmosphere, means the surrounding, or the pressure of the gas
Pressure
inside?
of the atmosphere. That's basically against that you're working. Is it clear?
Yes.
So pressure is constant. That is 101 kilopascals. Okay.
Yes.
All you need to do is convert this value to centimeter cube. That is all you need to do. Okay. Get it?
Yes.
Okay, write this down, please. And then we'll see each other in the next class. I my 8 class starting now, so that's why.
So you wrote centimeter square, centimeter cube, right?
So where did I write square? It's cube. It's cube. It's cube. Okay. All right, kids. So I expect you guys to do this question before tomorrow's class. And then I'm going to see you in the next class. Have a nice day. Bye.
Thank you, sir.
Love this.